Hi everyone, in this class we are going to learn D and F block elements. First of all, we should know what is D block elements. D block elements from third group to 12 group, from the group 3 to group 12, it is called as D block elements. So in the D block elements only, after the element lanthanum and after the element actinum, it is called as a F block elements. So D block elements are commonly called as a transition elements, and F block elements is commonly called as inner transition elements. So F block elements we will discuss later. As of now we are going to discuss D block element. So D block elements are classified into 4 series. One is 3D series, 4D series, 5D series, 6D series. 3D series means first series, first transition series. 4D means second transition series. 5D means third transition series. 6D means fourth transition series. When we are talking about the D block element briefly, D block elements. Here, D block elements or transition elements are those elements which have a incompletely filled D subshell in their ground state or in any one of their oxidation state. For example, in the first transition series, if I will take scandium, what is the atomic number of scandium? 21. So what is the electronic configuration? Argon 3D1 4s2. This is the electronic configuration of scandium. So here you can see incompletely filled d orbital. Only one electron is there. Hence it is called as a transition element. So now in between scandium to zinc, if you take from scandium to zinc, which element is not a transition element, and why we not considering as a transition element, that I am going to explain you now. So scandium to zinc, if you are taking, the electronic configurations are, you can have a look on the screen. Here you can see scandium is having 3D1 4s2, titanium is having 3D2 4s2, vanadium is having 3D3 4s2, chromium is having 3D5 4s1, manganese 3D5 4s2, so on. Iron 3D6 4s2, 3D7 4s2, 3D8 4s2, copper 3D10 4s1, and zinc 3D10 4s2. Now moving to the electronic configuration of transition elements. The general electronic configuration of transition elements is n-1 d 1 to d 1 to 10 and ns 1 to 2. So now here n-1 means if outermost n, if it is a 4, then it will be 3D like 4 is there, n is equal to 4, so 4 minus 1 d, that means 3D will come. If it is 5 is there, then it will be coming 4D. If it is 6s is there, then it will be 5D, so on. Okay, that all those things we are going to study later. In that, first we will discuss the electronic configuration. I have already shown that. Once again, have a look here. If you see the first transition series, here you can see the two elements having an exception, chromium and copper. Chromium, according to the first transition series, if you see, scandium is having 3D1, titanium 3D2, vanadium 3D3, but and chromium should get 3D4. But here what is there? 3D5 is there. So 3D5 4s1 is there. Instead of 3D4 4s2, what is there? 3d5 4s1 is there. For copper, instead of 3d9 4s2, what is there? 3d10 4s1 is there. So what it indicates, when we are studying the 11th standard, during that time we discussed the stability depend upon the half filled and completely filled orbital. If a half filled is there and completely filled orbitals are there, then the elements will get extra stability. In order to gain this extra stability, chromium and copper is having a half filled and completely filled electronic configuration. Same trend we can see in the second transition series also. For example, molybdenum we can, if you take, so molybdenum having krypton 4d5 5s1 instead of krypton 4d4 5s2. And if you take the silver of same group, that is having krypton 4d10 5s1 instead of 4d9 5s2. In the third transition and fourth transition series also, we can have this type of exception like gold in the third transition series. Gold having xenon 4f14 5d10 and 6s1 instead of xenon 4f14 5d9 6s2. In the fourth transition series, ruthenium is having radon 5f14 6d10 7s1 instead of radon 5f14 6d9 7s2. So these are some exceptions. In order to gain extra stability, they are having this type of completely and half-filled electronic configuration. Due to that, there will be a variation in the electronic configuration. The electronic configuration of outer orbitals of, if you are talking about the zinc is having argon 3d10 4s2. So what is our definition for transition elements? That is the elements which have incompletely filled d orbital in their ground state or in the any one of the oxidation state. So zinc is having +2 oxidation state. In the +2 oxidation state, zinc will become argon 3d10. This 4s2, these two electrons will be removed. So again 3d10 only is there. Again it is completely filled orbital is there. 3d orbital is there. Hence zinc is not considered as a transition element. But it is present in the series of the it is present in that period, hence it is called as, it is belongs to the d orbital only, but it will be not showing any transition elements properties. Same way you can see the electronic configuration of the second transition series, third transition series and fourth transition series. So the same trend I have told you in the zinc, why zinc is not considered as a transition element, same trend will be observed in the second transition series, third transition series and also fourth transition series. If you are talking about the second transition series, cadmium is the last element and the atomic number of cadmium will be, atomic number of cadmium is 48 and the electronic configuration, ground state electronic configuration will be krypton 4d 10 5s2. So this is the ground state electronic configuration. So I already told you in the zinc how it is possessing +2 oxidation state. Same here, cadmium also having a +2 oxidation state. So in the +2 oxidation state, cadmium will possess krypton 4d 10. So these two electrons is going to remove, hence it will is not considered as a transition element. Same trend you can see in the third transition series, that is mercury, and in the fourth transition series, that is copernicium, you can see. Hence these four elements like zinc, cadmium, mercury and copernicium are not considered as a transition elements. So now you know the idea about first transition series. First transition series containing scandium to zinc. Second transition elements containing yttrium to cadmium. Third transition series lanthanum to mercury. But here you should have a knowledge about in the third transition and fourth transition series, that is, if you consider the third transition series, lanthanum is there. Lanthanum atomic number will be 57. After 57, second element of the third transition series, you will be getting hafnium. This hafnium, what is the atomic number? 72. In between these 14 elements, these 14 elements are in the 4F series, that is F block elements. So these 4F series is also called as a lanthanoid series, and these lanthanoid series we are going to study later. After hafnium to mercury will be there. So that is 72 is a hafnium to mercury, that is 80. So these elements are belongs to the third transition series. That means lanthanum, after lanthanum 14 elements will be not there, directly hafnium will come, 57 to 72 you can see the screen. Then from there to mercury. The same trend you can observe in the fourth transition series, that is from the atomic number 89, that is the element is actinum. After actinum directly till 103, these 14 elements are in the 5F series. This 5F series is it is also in the transition elements, that is F block elements. So after 89, this 89 is there in the fourth transition series. So after 89 directly which element will come? 104th will come. So here actinum, that is 89. Then afterwards Rutherford 104. From here it will be continuous to copernicium, that is Cn 112. So this is the general information regarding the transition elements, that is D block elements, and along with their series, that is first series, second series, third series and fourth series, and what are the elements will come, and what is their electronic configuration, and which all the elements are considered as the transition metals, and what are the exception you can see, that all those things we have learning in this video. In the upcoming video I will explain about the general characteristics of transition elements. Until my next video, keep practicing, keep learning. Thank you.